Good morning. Once again, welcome to Physics STPM. The previous lesson, we learned about projectile, mainly theoretical. Now we are going to do solving some problem. Show you how to solve the problem. Let's just summarize what we have learned about projectile. It's called motion in a plane or two dimension or non-linear motion. If you send it up, that's the velocity of projection, that's the angle of projection. And then you will go follow this path. This is called a trajectory. And for the same height, the distance traveled is the range R. Right? So to start, we resolve the velocity into horizontal component and vertical component. Right? Remember, there is no air resistance for this part. So if there's no air resistance, then horizontal component, horizontal velocity is always the same. It's always there until you reach the ground. Vertical component is different. Vertical component, we have to use this equation of uniform acceleration. Right? When it's going up, this vertical component will decrease because of deceleration, decrease until it's zero at the maximum height. Then in reverse direction, because it's coming down, it starts to increase, and it's the same. Whatever you go up, it's the same as the speed you come down, except direction is different. Direction is downwards. This one is upwards there. Horizontally, it's still the same. And then we have derived the time of flight. And we say that time of flight, just consider vertical motion. But vertical motion, we use this component. And then we choose outwards as positive, acceleration is downwards. And you want to find the time. And then when it comes down, it's negative. This is the alternative symbol. So it's the same as initial speed, except the direction is downwards. That's why we put a negative sign there. Then for maximum height, we consider vertical motion also, because how long is spent in the air will determine how the maximum height. Right, same, we use the vertical component, this component. And we take ours as positive, g is minus, maximum height is h. And then the velocity at that maximum height is 0. Vertical velocity, remember. Then range, right? That's the formula that we have derived. We consider horizontal motion. Right? How long is in the air is determined by the time of flight. And then we just, that's the time of flight times the horizontal component, this component. Okay? This one tells this is a symbol for velocity initially in the x direction. Some author use, well, you can use ux, understood as initial velocity in the x direction. And for maximum range, that range, maximum range is for same height. We put this one 45, and it become 1. So this will give you a maximum range, u square over g. Right? And we look at effect of air resistance. It affects both the vertical and horizontal component. So it affects the velocity and acceleration. So the height is lower where there's air resistance, and the range is also lower. Right? Because the horizontal and vertical component are affected. Okay. I saw some problem. A stone is thrown horizontally. Remember the term horizontally from the top of the cliff with velocity 20. You can imagine that is your stone thrown at the top of the cliff. The stone reached the sea 3 seconds. Reach the sea below in 3 seconds. Calculate the height of the cliff. So the height of the cliff is determined by vertical motion. So I have given the vertical time. Right? And remember this 20 is for horizontal velocity. 20 is right. Vertically, it's just like dropping down. The initial velocity is 0. Right? And that's the range. That distance from where you start to where it drops into the sea is called the range. Height of cliff is determined by vertical motion. Right? Because it's determined by how long the object is in the air, or how long the stone is in the air. Right? And remember that we are dealing with vectors. Take downwards as positive is our choice, more for convenience because we would want to go with negative. So in this case, we choose downwards as positive. So initial vertical velocity is 0. G is downwards 9.81. Then our time is given 3 seconds. We want to find height. Right? So choose the right formula. S equals to ut plus half at squared. Substituting into the formula, u is 0, t is 3 plus half. A is 9.81. T is 3. So use calculator. 44.1 meter. I can leave your answer either as 2 or 3 significant figure because they only use 2, 3. Right? Distance from the cliff at which the stone strike the sea. We want to find that distance. And then the vertical velocity of the stone before it enters the sea. Vertical velocity here. The resultant velocity of the stone before it enters the sea. Right? You're looking at here. The vertical component before it enters the sea, and also the resultant velocity as it enters the sea. Okay, so let's look at this distance, the range. Distance from the cliff. So we consider horizontal distance or range. We consider horizontal motion, which is uniform velocity. So horizontal component of velocity, which is 20 times the time, we get our range, 60 meter. Right? Vertical velocity here, at this point before I reach the sea. Okay, consider vertical motion. Right? Note down what is given. Then can choose the right formula. Okay, you want to find V. So V equals to U plus AT. Right? We choose downwards as positive again. In your value, U is 0, vertical component is 0. A is 9.81, T is 3 seconds. Calculate out. It's 29.4 meter per second downwards. Right? Vertically downwards here. Calculate the resultant velocity. That means the velocity it reached the sea. Okay? So horizontally it's still the same, 20. It hasn't changed. Vertically we have calculated 29.4. So all we need to do is these two are perpendicular, we complete the rectangle. And then that's the resultant velocity. Okay. Remember it's a velocity, we need a direction, that angle there. Okay. So we can redraw that. You can use this picture, or you can use the triangle of forces. That's your 20. Right? And then there's your vertical one. That's your vertical 10.4. That's the resultant. That's your alpha. Right? Horizontal velocity doesn't change because there's no air resistance. So we want to find your resultant velocity. use Pythagoras theorem, 20 square plus 29.4 square, square root the whole thing, calculate out. Using calculator, then we want to find this angle, given the direction of the velocity to the horizontal. Tangent is 29.4 divided by 20 is 1.47. In your calculator, 55.8 seconds. Sorry, 55.8 degrees. Okay. We cannot add a scalar because velocity is a vector. We have to add it as a vector. A baseball is thrown with initial velocity 100 meters per second at an angle of 35 degrees. Yeah, draw a rough picture. That's your ground. That's your ground. Orange line. That's the velocity of projection, 100 meters per second. That's the angle of projection, 35 degrees. Calculate the maximum height. Okay, we resolve the component. Horizontal component is 100 cos 35. And we just replace the velocity, that one, horizontal, and now the vertical one is 100 sine 35. So maximum height, consider vertical motion, taking outwards as positive. So that's our velocity, this one. Vertical velocity, calculate using calculator. What are the things given? Acceleration is given, 9.81. We take outwards as positive, so acceleration becomes negative because it's downwards. Maximum height velocity is 0. Then we want to find height, s equals to h. Choose the right formula. B squared equals u squared plus 2as. Put your value inside. Calculate using your calculator. Right? Time to reach maximum height. We can still use the same what is given. All these variable that all these variable parameters that have been given, and then calculate the time. Okay, that is what we have calculated. V is 0. So to calculate the time, use V equals U plus 80. Put in your value, your U, that's your U. A minus 9.81, T, and then the velocity, and the maximum height is 0. Okay, so we can take this across there, and cross multiply 57.4 divided by 9.81. We get 5.85 seconds. Time of flight. Okay. Yeah. Time to reach maximum height, we calculated. Time of flight is 2 times this time. Time to reach maximum height because the time to go up and the time to go down is the same. So we just multiply by 2, 7.7 seconds. Range. In range, we consider horizontal component of velocity. Time of flight, we have already calculated. So range, consider horizontal motion. Distance is horizontal component of velocity times your time. Right? That's a horizontal component times your time. 958 meters. We want to calculate the velocity at 5 seconds. Right? So as before, we consider vertical motion. Right? This one tells us this is the time to reach maximum height. That means this ball has not reached maximum height yet. It's still in the positive direction. Take ours as positive. Right? I give you a rough idea. Answer should be positive, not negative. Vertical component is the same. Right? We want to find vertical velocity. Consider vertical motion. Initial vertical velocity. We take ours as positive. So our G is 9.81 downwards. Right? We want the time at 5 seconds, velocity at 5 seconds. Right? Calculate your vertical velocity, V equals U plus 80. U is that. plus A is 9 minus 9.81, answer 5. In calculator, calculate that out. Right, so we have calculated the vertical velocity, 8.35. Horizontal component is this value, 100 cos 35, 81.9. Remember, the horizontal component doesn't change when air resistant is negligible. So the horizontal component, so the resultant will just be the red line. That's the resultant velocity. Right? We need an angle because it's a vector, alpha. The resultant velocity using Pythagoras theorem, 8.35 square plus 81.9 square, and the whole thing with square root it. Using calculator, calculate out 2.3 meter per second. And the angle, tangent alpha is opposite over adjacent. Calculate, calculator, 9.8. Alpha is 84.2 degrees. Okay, let's try some of the past year question. A football is released above a plane sloping, there's a sloping surface, and bounce, right? There's the bounce. Several times, the diagram shows a path between the bounce at X and Y. Okay, is one of the bounce. Assuming there's no air resistance, which of the following graph correctly shows a variation with time of the horizontal component of velocity between X and Y? Right? Remember, horizontal velocity is always constant. Doesn't matter. You need to apply your knowledge. Right? There's a velocity initially. Right? So horizontal component is always constant. There's horizontal component. Right? Horizontal component of velocity is constant. So answer is B. If you are looking at the speed, vertical speed, then this is the answer. Right? The speed will decrease, then after that will increase back again. Right? Speed we are not interested in direction, so there is no negative sign. But we are looking at velocity, vertical velocity. Right? Vertical velocity will be highest, then it decrease to 0, then increase. Right? Something like that. Except this one will be further away. Same like here. This one will be further away. Because it will take, it's not the same height. Right? It will take longer time and the speed will increase. Vertical speed will increase larger. Same here. Okay, a projectile. Right? This is Cambridge question, November 2002, number 8. Projectile is launched at O and follows the path O, P, Q, R, S as shown. No air resistance. Which statement is true for the projectile when it's at the highest point Q? Horizontal component of projectile acceleration is 0. Right? Horizontal component, yes. Oh, sorry. Right? Vertical acceleration is not 0. Horizontal acceleration is 0 because it's not accelerated. Horizontal component of projectile velocity is 0. Wrong. There's no air resistance, so the horizontal component of velocity is still constant. Kinetic energy of projectile is 0. No, it is minimum, right? Because there's horizontal velocity, it has kinetic energy. Momentum of projectile is 0. No, momentum of projectile is horizontally here. That's a value. Answer A. Okay, horizontal component of velocity is constant. Air resistance is negligible. The horizontal acceleration is 0. Vertical acceleration, there is. It's not 0. Right? Since the horizontal component of velocity is not 0, as I explained earlier, kinetic energy is also not 0. Likewise, momentum is not zero because horizontal velocity got a value. At which point is the vertical acceleration zero? Any suggestion? No, it doesn't switch off. It's always there. So no answer. Right? G is constant at all the point. It's always downwards. Okay, I modify the question. Same question as before. Which statement is false for the projectile when it's the highest point Q of the path? Vertical component of velocity. Right? We want to look at the false statement, the untrue one. You want the correct one. Vertical component of projectile velocity is zero. This is true. Vertical acceleration is zero. No, this is false. Right? It doesn't switch off. The G is still there. Only horizontal component disappear. Kinetic of projectile is minimum here. You only have got horizontal component, vertical component is zero. Momentum of projectile is horizontal. True. You only have got horizontal velocity. Right? So your answer is B. Okay, a tennis ball is thrown horizontally in air from the top of a tall building. Usually when we talk tall building, air resistance is not negligible. Right? Sometimes they are kind to you, they will tell you if the effect of air resistance is not negligible, well, air resistance is there. What happens to the horizontal and vertical component of the ball's velocity? Right? Horizontal component is normal constant now, it will decrease to zero. Right? If possible, it may reach zero. Vertical component, right, is thrown horizontally. The vertical component, remember the acceleration is downwards, the air resistance is upwards. So it's normal constant. Vertical component of velocity is normal constant. It will still increase, right? But not at a constant rate anymore because the air resistance is coming in. G is normal, acceleration is normal constant, right? It's normal G. Right? There's an opposing force. The weight is pulling it down. Air resistance is trying to stop it, so it's opposing it. So the resultant force is going to be smaller. Acceleration is going to be smaller. But it will still reach a maximum speed. The speed is still increasing. If air resistance, horizontal component of velocity decreases to zero. Vertical component increases until maximum value. Right? You see, we still got a height, then you move with terminal velocity. That's what it means by maximum value. Where it reach terminal velocity, that means the air resistance equals to the weight. You cannot increase any more air resistance, right? Increase the weight. So that is where terminal velocity occur or maximum velocity occur. The answer is donkey. D. Okay. Projectile is fired from ground at time t equals 0. It lands back on the ground at time t. Which of the following sketch graph best shows a variation with time of the vertical velocity v and the horizontal speed, vertical speed v and horizontal speed vh of the projectile. Air resistance is negligible. Remember, we are looking at speed, it's a scalar, so not worry about direction at all. Right? So it's fired from ground at time t equals 0. So it fired means initially it has a horizontal component and no air resistance is constant. Okay, so it's either these two answers. Horizontal component constant, but vertical one, you are interested in speed. Right? So the speed will start with maximum, decreases to 0, and then as it changes direction, right, as it's coming down, the speed starts to increase again to maximum at time t. Right? Horizontal component of velocity is constant. Right? So this is a horizontal line. Vertically, the velocity is maximum at ground and decreases to 0 at maximum height, right? At half t, which is here. Then as the projectile falls, its speed increases to the speed where it's projected at time t. Right? Remember, t is a scalar quantity. We can use roughly this equation, which is for vector, to roughly tell us it's a straight line. Right? It's a straight line with negative slope. If we take it as a vector, the answer is B. Okay, here's an old question. Yes, use scale drawing if you want to. A stuntman, as a stuntman on a motorcycle, plans to ride up a ramp in order to jump a number of cars. These are your car. The speed of the motorcycle as it leaves the ramp is 14 meters per second. Neglect air resistance throughout this question. On figure 1.2, the line OA represents the velocity of the motorcycle just as it leaves the ramp. Explain why OA represents the velocity of the motorcycle and not just the speed. Right? OA got a direction, 30 degrees, got magnitude, so it's a vector. Okay. So A, it gives magnitude and direction. On figure 1.2, construct line to determine the horizontal and vertical component of the velocity of the motorcycle. That's what we did. Right? We solve it, draw a horizontal line, vertical line, then complete the rectangle. The rectangle, and you can draw the horizontal component of velocity, vertical component of velocity. Okay, so our horizontal component is 14 cos 30. Vertical component is 14 sin 30. It's far away from the angle. Calculate the time interval between leaving the end of the ramp and reaching the maximum height. Consider vertical motion, taking hours as positive. So the vertical velocity is 7. Maximum height velocity is 0. G, we take hours as positive. So G is downwards, negative 9.81. We want to find the time. V equals U plus 80. Put in your value. V is 0. U is 7. Minus 9.81 T. Calculate your time. Okay. The cars are each of length 1.6 meter and the same height as the ramp. Estimate the maximum number of cars which the motorcyclist can jump from takeoff speed of 14 meters per second. Okay, we have to find the horizontal distance first. To calculate the number of cars, we need to calculate the horizontal distance or range. So we consider the time of flight is double the time to go to maximum height. And to find the range, we calculate horizontal. We use horizontal motion. Right? Horizontal motion is uniform velocity, so it's speed times time, or velocity. Horizontal velocity times your time. So horizontal component velocity is 12.1. That's the time of flight. Get our range or horizontal distance travel. Right? Number of cars, the range divided by the width of the car, 1.6, get 10.8. Right? Remember, we cannot round it off. It doesn't reach the 11th car, so it's only 10. Right? It will fall on the part of the 11th car. Note, time of flight, remember time of flight, time is in the air, because the 2 times time to reach maximum height, cars cannot be round off to a whole number. It's either a full car, not part of a car. Horizontal motion, uniform velocity. Okay, let's try another question. Past the paper. A golf ball is hit with a same force and direction on Earth as on the moon. Which diagram best represent the shape of the path taken by the golf ball? It's an application of your knowledge. Okay, so on the moon, there's no air resistance. At the same time, gravity is smaller. Gravity is smaller. So it can go further, right? Because it can go to higher height and it can also go further. Right? On the moon, G is smaller, so the ball will spend more time above the ground. So it would move further than on Earth. On moon, there's no air. That's your general knowledge. So no air resistance. The answer is C. On Earth, because of air resistance, it's not going to be symmetrical. On moon, no air resistance, so it's symmetrical about the maximum height. A stone is projected, this is also past paper, horizontally in vacuum, key is vacuum, and move along the path. They draw for you the path. X is the point on the path, that's your X. XV, that's your XV, and XH are vertical and horizontal line respectively through X. XT, that's your XT, is the tangent to the path at X, along which direction do the force act on the stone. Right? Horizontal component of velocity is there. Horizontal component doesn't change, vertical one becomes longer. We are looking at velocity, that's the velocity, the resultant velocity along t. But we are interested in which direction do the forces act on the stone at X. Okay. Remember, it's vacuum, no air resistance. So horizontally, there's no force. Only downward pull, the weight is pulling it downwards. Okay. In vacuum, there's no air resistance, so no horizontal force. Vertically, the force acting is gravity, so it's the weight of the stone, which is downwards. So answer is A, XV. A football is dropped from the top of a tall building. Which acceleration time graph best represent the motion of the football through the air? And remember, tall building, air resistance is not negligible. You have to consider air resistance. So if there's no air resistance, then that's the answer. Acceleration is always constant, right? It's downwards. If we take downwards, it's positive. But because of air resistance, the weight is pulling downwards. At the same time, the air resistance is opposing. Right? It's moving downwards, air resistance is upwards there. So the resultant force becomes smaller and smaller. Right? Weight minus air resistance. Air resistance increases as the speed increases, which we'll study in the next topic. So the resultant force becomes smaller and smaller. So the resultant force is the one that gives the acceleration. So if the resultant force becomes smaller, the acceleration also becomes smaller. Right? It's normal G, it starts with G, it decreases to 0, where you reach terminal velocity. Right? So the football is dropped from a tall building, air resistance would oppose the motion. So acceleration decreases as speed increases. So answer is C. Okay, this is also a partial question. Distinguish between scalar quantities and vector quantities. Scalar quantities have only magnitude, while vector quantities have magnitude and direction. In the following list, underline the scalar. Right? Kinetic energy is scalar, mass is scalar, power is scalar. Right? Underline that. A stone is thrown horizontally with a velocity of 20 meters per second. Remember, this is horizontal velocity from the top of a cliff, 15 meters high. The path of the stone is shown. Air resistance is negligible. Right? That's the key, no air resistance. For the stone, calculate the time to fall 50 meters. Right? The time to reach here. So you consider vertical motion. Right? Consider what is given. Right? Height, vertical height is given. That one. Initial speed is also 0. Right? This is horizontal speed. Remember, horizontal velocity. Vertical is 0. Take downwards as positive. So acceleration is 9.81. Choose the right equation. S equals ut plus half at squared. Put in your value. S is 15. U is 0. Then half is 0.5. A is 9.81. And t squared. And using your calculator, we got 1.7 seconds. Calculate the magnitude of the velocity or the resultant velocity after falling 50 meters. Okay, so the velocity will be in this direction. So before we can calculate the velocity, we have to calculate the vertical component first before it reach the before it reach this horizontal level. And then horizontally is the same. It doesn't change, no air resistance. Draw a rough picture. Horizontal velocity doesn't change. Vertical velocity, that's what we want to find. Right? Calculate the vertical velocity as the height. Initial velocity is 0. Acceleration is 9.81. So use your v square equals to u square plus 2as. Put in your value. Initially, u is 0. 2, 9.81. Height is 15. You get 17.16 meters per second. Okay. Sorry, there's a careless mistake here. This one has been square root. Okay, so I've got horizontal, got vertical velocity, then we just complete the rectangle and then find the resultant velocity. And remember, it's a vector, you must have a direction. Either this angle or the angle must be found. Resultant velocity using Pythagoras theorem, that square plus that square, and take the square root, get 26 meters per second. Right? We are interested in magnitude only, so we don't have to worry to calculate the angle. Describe the difference between displacement of a stone and distance that it travels. Right? Distance is the actual path travel. Displacement is the straight line. Distance between start and finish point. Right? Must apply. Right? Not simply define distance travel in a specific direction. Right? Must define it clearly to the examiner on a minimum distance. Right? So you are asked to draw, can draw. That's the distance, the actual path to travel. Displacement where you want to, where it start to where it stop, just draw a line. Okay, thank you for your time. We have finished the lecture. The next topic will be dynamic. Keep a lookout. Right? This will be posted on Facebook and YouTube. Yeah.